thank you for meeting with me. How's PCIM going so far?
Actually, very well. I arrived this morning, right?
Yeah.
So our booth is very well visited, so
Yeah.
a lot of people, and I think we can also show quite some compelling and interesting innovations. So
Yes.
I would say expectations so far very well met.
Very good. Maybe we could start off with, say, the Spain blackout back in April of last year. It knocked out power for tens of millions of people for hours. What did that tell the industry about where the vulnerabilities are in the grid?
Yeah, I think this particular example shows how important resilient infrastructure is, right? And I think it made us aware that if the resilience is not in focus, right, then it may harm a lot of people and economy, of course, right?
Yeah.
So I don't know exactly what it's estimated as a value being destroyed due to this blackout.
Yes.
But it again puts into focus how important it is to invest into these kind of things, into critical infrastructure, where of course electricity supply is one of the very, very big topics of today.
Yeah.
And I think still today it's not completely clear how it happened, right? And I think a multitude of issues were causing it. And that shows, of course, also that we need to invest into stability and resilience of our grids.
Yeah. So it seems there's unprecedented new energy demand on the grid from data centers and AI training, but on that same grid you have renewables that destabilize, the supply. How is the semiconductor industry positioned to solve both problems?
I think luckily we are, from our perspective, in the middle of a solution of the challenges and problems that you highlighted. On one side, with the trend for energy generation shifting more and more towards renewables, the share of semiconductor content, of course, also increases. That is good for a semiconductor manufacturer as
Certainly,
we are.
yeah.
So, then, of course, while you are increasing the share of renewables in energy generation, you have the challenges related to the grid. First of all, we have time dependence of renewables, right? In the night, no sun is shining, and also the wind is not always blowing. There's the famous saying in Germany, the Dunkelflaute, it's a German word, which means there's no sun shining, especially in winter, and also no wind blowing. Right?
Yes, yeah.
And then if you depend solarly on solar and wind, you have no energy, right?
Yeah.
So how to overcome it? I think one answer, not the only one, but one answer is of course storage, so that you have battery storage systems which are able then to at least bridge over some time, right? These kind of shortcomings, and then of course the grid of the new designed grid of the future has multitude of components. Beside renewables, also gas energy, batteries for stabilization, and the critical change which you and we face then is that instead of unidirectional energy flow from very big centralized power stations, the grid of the future has a multitude of components where you need bidirectionality. So energy has to flow back and forth. And instead of producer only, consumer only, you have the so-called prosumer, right? Yeah. Where also private households or smaller businesses entertain their own PV system on the roof, or even a bit larger commercial industrial PV systems. And either they consume themselves the energy, or they have the capability to feed it into the grid and help to stabilize the overall system. So a lot of things to play around, and luckily for us, everywhere semiconductors are needed.
Well, thank you for answering that. Maybe we can cover the new solid-state circuit breaker announcement here at PCIM. Could you talk about that in a little bit more detail, and what could that mean for how electrical protection in data centers and grid infrastructure will advance power going forward?
Yeah. That's another, I would say, building block related to the topic we discussed before. First of all, let me say that and we are very grateful to have found Siemens as a very committed and dedicated customer of ours, and together we develop those kind of solutions that Siemens is selling to their customers, right? And the solid-state circuit breaker is basically the component which is enabling future DC grids. So the topic of DC grid has been around for a couple of years. Firstly, pursued by the industrial use cases, where it was always very clear that certain DC grid has advantages, but also related to standards. It was not a fast mover, let me say like this, right?
Yeah.
So you have an approach and a way to make use much more efficient of energy, but the real push now for DC grid and for the adoption of DC grid comes also from the AI data center architecture. The AI data center architecture is evolving in a way that late in the current running decade, it's expected that AI data centers will shift to 800 volt DC supply. And for the DC grid supply, you need the solid state circuit breaker and the electrical properties, which can be only fulfilled with help of semiconductors. And that's basically the key component. And the critical topic is that in case of an event, the switch has to protect, of course, the infrastructure, right? In case of a, for example, short circuit event, and the semiconductor is capable to switch much, much faster, 3 orders of magnitude faster than the so far classical electromechanical solution, and therefore it makes it such an attractive product offering.
Maybe we could move to the CoolSiC JFET family. Infineon launched that last year, and that's targeting SSCBs. Conventional mechanical circuit breakers operate in tens of milliseconds, and SSCBs can interrupt faults in microseconds. So how significant is that for grid resilience and data center power distribution? Could you talk about that a little bit more?
I think the advantage you already mentioned, the big difference and the benefit from a JFET is the following. The traditional MOSFET is a switch, meaning turning on and off.
Yeah.
This is a use case which is not required for a solid state circuit breaker, because typically the circuit breaker is normally on, right? It needs to conduct, but just in a fault case, it has to disconnect basically the load. And the lucky thing is that exactly that is the property of a JFET. The JFET is a normally on device which conducts just in case it shall not, right? It switches off. Yeah. And therefore also from a cost performance consideration for the solution, the JFET is the preferred choice for these kind of applications. And therefore customers are asking for these kind of solutions, and we are happy that we have now provided the first solution, and while we speak we are expanding our product portfolio in voltage classes and also in package offerings, which are, I would say, on high demand from our customers. Maybe
we could talk about the packaging and interconnect technology. So that's being worked on, and that's where a lot of performance differentiation happens at that package level, not just the semiconductor itself. So I know Infineon's been investing heavily in the .xt diffusion soldering, advanced ceramics, and direct liquid cooling. So how significant are those innovations in determining real-world performance, in these applications?
Yeah, I think it depends on the use case. Those technologies come with additional performance, with additional features, as you have said, and so it depends on the application, on the customer, if it's required, right? Okay. So we have you can think of kind of a building block that we can make use of. So if you have an application which requires high ruggedness with respect to temperature, with respect to power cycling, then those kind of building blocks are the perfect solution. And therefore, if you have more applications and customers who are very much cost driven, right, then we adapt and then we may use standard technologies, which of course don't deliver the highest performance, but so to say standard performance, right? And I think one strength of our product portfolio is that we can adapt depending on application and customer requirement our offering. And that is true not only for discretes, but also modules and all other form factors in packaging technology.
Thank you. Last question. So we're here at PCIM. Is there anything new from Infineon this week that we haven't covered that you think we should talk about?
I would like to invite you and show around a bit at the booth. I think what is very impressive is our end-to-end offering, especially if you now think about AI data center, but of course also industrial applications. We are one of the few companies being able to offer really end-to-end solutions. So with respect to power semiconductors, everything from energy generation, from energy transmission into distribution, and then of course also into supplying processors, core, and also physical AI robots, right? These are all solutions that we can provide to our customers and that you can showcase, or we showcase at our booth.
Yeah.
And therefore,
Yeah.
happy to invite you to show you around at the booth.
Yeah, I'll be there. Thank you so much. I appreciate
Thanks.
your time.
Pleasure.
Thank you.